look at this. It works. My goodness. And it was so easy to do, too. This is going to be my science fair project. Yeah. Woo, look at it just blows and spins and spins and spins. And woo, look at that. It's so much fun. Yeah. Hey, Mr. Z. Mr.
Watson.
Z, come here. Look at this. Look at this.
Is this what I've been hearing so much about?
Yeah.
This is the science fair project. All right, we're going to find out what Watson's up to here. What's this supposed to be?
Well, it's supposed to be a windmill.
A windmill? Oh, so you're like Don Quixote, huh? You're building a windmill.
Yeah.
So what's the idea? You trying to make a better windmill?
Sure.
All right, well, that's a great idea. In fact, today's program called A Fair to Remember is all about science fair projects. And if you're trying to find out what to do this year, if you don't know where to start, you're trying to get an idea, and you want to be a winner, because I know Watson wants to take home the big prize.
Yeah.
We're here to tell you how it's done. We're going to take you to the regional science fair and show you some past winners, give you some ideas on how to do it right. And to help us along as well, we have Mrs. Winnie Woolley here, who's the director of the
Watson.
Owen Science Center in Greenbelt, and she's the judge, Watson. So be careful.
Okay.
Here comes the judge, and Winnie's going to tell us what judges look for in science fair projects. So let's find out if your windmill has some possibilities. Winnie, thanks for coming by today.
Thanks, Dave. Now, Watson, you must remember that your project must be something that you can manage. First thing the judge looks for is procedure. Is it something you can do? You might get help from Mr. Z, but you must be able to do this project on your own. Now, the other thing is planning. You have to set up a plan of action for your project and do that. Now, the second thing that the judges will look for is the project development. You must do the scientific method, Watson. Now, you must have a procedure. You must write in your purpose. Why are you doing this? Then you must collect all of your data. Now, with your windmill, you know, I believe, Watson, that you could possibly change maybe the sizes of the blades. And then you would have to collect data on what happens with one size, and then another, and then another.
Oh, I see. We can see which one works the best.
Yes.
Yeah.
Now, Watson, you must also be creative in what you do. So when you want to change something, you think about it and you change it. Then you draw a conclusion from what you've done. Now, the key thing, there's one other section, Watson, and that's on your presentation to the judge. Now, first of all, in case you're not there when the judge arrives, you must set up your exhibit, Watson, so the judge will know exactly what you've done. You will have a statement to begin your exhibit that will tell the judge what you found out in your project, your conclusion. Then you'll have the purpose, you'll have your graphs and your data there for display, and then you'll have your conclusion written out in a simple statement, Watson. Doesn't have to be books and books of information, just a simple statement. You understand that?
Yeah, I sure do.
Now,
Winnie, I've never heard him or seen him this quiet before. Are you taking all this in, Watson?
Yes.
All right.
now the last thing is the interview with the judge. Now, you need to tell the judge all about your project. You need to be familiar with every part of that project, Watson. Now, the other thing you have to do is answer the judge's questions. And when you don't know, you'll think about it, and then you just tell the judge your best answer. Now, if you do all of these things, Watson, you are certain to be a winner.
Oh,
and
good.
I'm going to come to the regional fair to see your project and how well you've done.
Well, that's very nice of you.
So, Watson, you know the judge is going to be there to see how well you learned your lesson today.
Oh.
And of course, Winnie knows, as all of us teachers know, that just by participating, you're a winner.
Yeah.
Even if you don't take home a prize, just by going through all the steps you just heard, the procedures and the purpose and displaying the data and coming up with a conclusion, you have proved yourself that science works, and that's worth more than any prize that we can give you. Now, keeping that good advice in mind, we want to see if this windmill tilts the right way or the wrong way, because we'll be back later after we talk to some students who actually did win, and we'll design Watson's experiment according to Winnie's directions. So stay with us. We'll be right back.
Yeah, turn it on, Mr. Z. Turn it on.
All right, here we go.
Yeah.
We're here at the Largo Student Center, and this is the Regional Science Fair. Everybody recognizes Watson. And this is Jean Wang, the second Grand Award winner in between here. And Jean is from Roosevelt High School. She's a sophomore, and she has a project she'd like to tell you about. So if you're out there wondering, boy, could I win an award like Jean did? What do I have to do to get a science fair organized to win? Jean's going to tell us. Jean, thanks for being with us today.
Thank you.
Hi, how are you?
Don't mind him.
Yeah.
He's going to have a few questions for you as well. Gene, the title of your project is Preventing Browning of Fruit Tissues. Now, what gave you the idea to do this?
I love to eat apples, and I was biting into an apple and I noticed how quickly it turned brown. So I was just wondering, for people preparing dishes with apples in them, how they could preserve the apple from turning brown since it's undesirable.
Well, you're talking about something that interests Watson. Eating.
Yeah.
He's
I like-
always interested.
I like to eat apples too, yeah.
So Gene is a little bit like Isaac Newton. I guess Isaac got hit on the head with an apple, and Gene happened to be eating one, and that gave her an idea of what to do. Now, did you form a hypothesis, Gene? What did you guess at the beginning might be the result?
Yeah, well, since oxygen causes it to turn brown, so I thought by using chemicals which would help the fruit resist oxygen would stop it from turning brown, and that was correct.
Okay, and what kind of chemical did you find was most effective?
I found that a combination of chemicals, like a 0.1% concentration of ascorbic acid and a 0.5 concentration of citric acid, was the best combination in preventing browning.
So if you're out there and you have some orange juice for breakfast and you have some apples on your cereal, a little bit of orange juice on the apple might prevent that kind of browning. Now, Watson here, as we said, Gene likes food.
Yes.
And he frequents the salad bars here in Prince George's a lot. Gene, is there a problem at salad bars when they try to prevent the fruits and vegetables from browning?
Well, yeah, they used to use sulfites, but they were recently banned. So I think now they use lemon juice or something like that. That contains citric acid, and so they might use this combination that I found to help stop the browning.
Gene, one last question. Now that you've done so well here, we know you're going on to another competition, to the international competition. That's in...
That's in Knoxville, Tennessee, and I think it's on May 8th.
May 8th. Now, where does this project lead? Now that you've finished it, I know it's not going to go home and gather dust. Do you have plans to continue your research on this or something else? And what do you hope to do in the future? Are you a future scientist?
Yeah, I hope so. And I think I'm going to continue this project and improve it and find out why it turns brown. And that might also give me some more ideas on how to prevent the browning.
Gene, that's good advice. And those of you that are listening, this is a great role model. Gene did this through hard work and a lot of help. I know she had resources. Her parents helped her. She went to the Beltsville Agricultural Center for help. Watson, do you have any comment or question for Gene before we leave?
Gee, well, this is a nice display. How long did it take you to put it together?
Well, the whole project took me 4 months, and yeah, I had to spend a lot of time on the backboard, make everything neat.
Well, it certainly impresses us, Gene. It looks neat. It's outstanding work. And Watson and I are going to go look at some other projects. Gene, thanks for being with us, and good luck at the International. Stay with us.
Thank you.
We just met Gene Wang from Roosevelt, and this is a colleague of hers. This is Jin Park, who is, are you a sophomore or freshman, Jin?
A sophomore.
Sophomore. And you have something to do with, your project has something to do with food as well, doesn't it? What's the title of it?
Neutralizing ability of antacids.
Of antacids. All of you out there who've ever had upset stomachs, pay attention, because Jin has some information to tell you how to get rid of it. Now, what gave you the idea to test antacids? Do you eat a lot of spicy foods yourself? What prompted it?
Well, I do eat spicy foods, but I was just plain curious.
Just curious.
Yeah.
So sometimes, to get an idea for a science fair project, just curiosity powers you. Now, we know that experiments always should have a hypothesis. You make a guess at the beginning. What did you figure would be the best antacid?
Milk and magnesia, because there's a way, like a pH system that I believe that milk and magnesia showed it was the best.
So Jin thought milk of magnesia would be the best. Did you hear that, Watson?
Sure did.
I know you've got a bottomless pit for a stomach.
That's
there.
right.
Antacid should be something you know about.
Yep.
Now, he guessed that it would be milk of magnesia, but in experiments, you always follow the scientific method. You have a title, then you have a hypothesis. What other steps did you follow? Because the students out there are going to model themselves on you, Jin. As you design an experiment for a science fair project, you have a title, you have a hypothesis. What other steps do you need?
Purpose, observations, and conclusion.
A purpose, an observation, and a conclusion. Do you also have a section where you list your results, where you have your data?
Yeah, that's under observations.
It's under observations. All right. Now, the big answer. You went through all of your procedures. You tested all these different antacids that we see behind us here. And Watson, listen up, because this could be important. Which one did you discover to be the best antacid?
Baking soda.
plain, ordinary baking soda, Arm & Hammer. And why was that? Why was it better than the others? What did you find?
Because of its price, and it had far more content than the others, and it was very high in quality.
Okay, so the quality was good, and the bonus was it was also inexpensive. If you had something to say to students out there, elementary school students, about designing a science fair project, any advice you have for them?
Just do the best, I guess.
Do the best you can. That's good advice in anything. Thanks, Jen. Watson, you ready to go look at another project?
Yeah, let's go, Mr. Z.
Okay, stay tuned. We'll be right back. Okay, we're still here at the Largo Student Center looking at some of the top-notch science fair projects from all over this part of Maryland. And we have another project behind us and another outstanding science student. Could you introduce yourself to the audience, please?
Hi, my name is Shereen Jahed, and I'm from Eleanor Roosevelt High School.
And you're a freshman. You anticipated my question. Can you tell us what your project's all about?
I did Can the Evaporation of Water Be Prevented? Because I noticed that every year a lot of water from reservoirs is wasted by the natural process of evaporation, and I wanted to see how this could be prevented, so I was using oil seals in my experiment.
Oil seals. Now, that would certainly be something that could benefit all of us if we could conserve water that way. Is there any way to prevent evaporation of water, did you find?
Yes, by using an oil seal with a thicker layer, I was able to prevent a significant amount of evaporation than with just no oil at all. So.
Now, Watson, what do you think about that?
Gee, I think that's pretty neat. Tell me, what gave you the idea for this project?
I just wanted to see how people could prevent the wasteful process of evaporation.
Gee, was it hard to do?
I spent a lot of time on it, yes.
Oh.
How much time did you spend?
A lot of weekends of research and then some final processes.
Now, one last question, Shereen. Where does this go from here? Now, are companies interested in what you've done? Because I can see some potential for this. And those of you that are thinking about science fair projects, don't think just because you're a student that the research you do is confined to your school. Many times companies are looking for the kinds of research that you yourself can do. It can benefit you. You can get awards, you can get cash prizes. Shereen, where does this lead for you?
Well, as a matter of fact, I did get an award from the Graduate Women in Sciences. They liked my project because it was an outstanding project for females in the science fair. So they gave me a lot of input on how to expand on my project. So I was thinking of doing that for next year.
So we're going to see you here next year?
Yes.
Okay, Watson, when we come back, we're going to make sure she's here. All right, you said that in front of everybody. Thanks,
sure
Shereen.
will.
Let's go look at another project. All right, we've been talking about experiments here at the science fair that have to do with food, something Watson's real interested in, but now we're going to burn off some of those calories. This is Jonathan Maddox from Frederick Douglass High School, and Jonathan has an experiment to keep you fit, so pay attention, and also he's got some good ideas on how to organize a science fair project. Jonathan, thanks for being with us.
Thank you.
Can you tell us, what does the title of your project mean? Health, physical fitness, and the recovery index. What's a recovery index?
A recovery index is a number that indicates how a person is physically fit. It tells them if they're in good condition or bad condition.
Okay. Now, you yourself, are you interested in physical fitness? You look like you're in good shape. Are you a runner?
Yes, I am. I run the track team for Frederick Douglass, and I also play soccer at times.
All right. Now, you've got something behind you here called the Harvard Step Test. Now,
Out of the way here.
Watson's going to step out for the step test. Jonathan, what's this for?
This is a small stress test for the people who are going to try my test. And what they have to do is step up and down on the step for 4 minutes. And the step here raises depending on their height, because they have to step up a certain height before they can do it. And I let them step up and down for 4 minutes, and then after that minute, I'll let them rest. And
Can you show us how that's done? Can you take a little stress test yourself?
okay, well, the people start off and they step up and down the step for 4 minutes. And
What does that do?
well, it builds up their heart rate, so it goes faster a little bit, and then they
So your heart's beating a little faster now.
Yeah, so
Yeah, I can do that, Mr. Z.
You'll get your chance, Watson. Just listen to Jonathan here.
okay, and then they can rest for a minute, and then after that minute, they have to take their heart rate for 30 seconds, and then I let them rest for another 30 seconds, and I do this 3 times through the experiment, And then after I get their heart rates, I can add all 3 of them up, and I can put it into a formula, which will give me the recovery index, and that will tell me if they're in good physical condition or bad or fair or very well.
Okay, so after you exercise, the amount of time it takes for your heart rate to go back to normal is the recovery time, the recovery index. Okay, so what were your results? It sounds like you've designed this well. Your display here is attractive. I can see why you have an award. What did you find out?
Well, I found out some people are in good physical condition, and that runners, they're in the best so far in my experiment, and they can recover from it better, especially long distance runners, because their heart is prone to it. They can run at longer distances and not be totally tired. Where people like one of my subjects was a football player, and I thought he'd do pretty well, but he's mostly sprinting back and forth on the field, and so his heart wasn't really set up for it, and so he had a pretty low recovery index for it.
All right, Watson, were you paying attention? You and Garfield the cat should listen to Jonathan. Okay, get out there and exercise, increase your recovery index.
Exercise all the time.
And science fair projects like this are easy to set up. Jonathan had a lot of help. Doctors helped him. He went in and discovered other resources, and that's what it takes to get an award-winning project. Good presentation, a good idea, and follow-through. Jonathan, thanks for being with us.
Thank you.
Yeah, thank you.
The 1988 Science Fair is winding down, and we're here at the Largo Student Center, and we want to get a perspective on what it's been like. Now, Watson over there thought we were coming to the county fair.
Yeah.
He kept looking for the popcorn and
That's
the
right.
peanuts.
Yeah, where are the rides?
Sorry to disappoint you, Watson.
No rides, huh? Okay.
Our 2 guests here, Dr. Jack Crable, one of the supervisors of science in the Prince George's County Public Schools, and Mr. George Woolley, who's the president of the Prince George's Science Fair Association. Gentlemen, as you look back over these past few days, as you look at all these talented young people and the projects they've brought here for us to see, what can you say? How would you summarize the 88 Science Fair? Dr. Crable?
One of the things that I notice is that there's a level of sophistication increases each year. Not only the quantity of projects, but also the quality and the sophistication each year seem to be growing and growing to a higher level. And that's very interesting because it isn't long before they adopt some new technology that the business world or the technical world has, and it shows up here the next year. It's very interesting to see that.
So a lot of the things we take for granted now, microwaves and better jets, really had their origins, I'm sure, in science fairs somewhere in this country.
Certainly.
Watson, did you hear that word that Dr. Crable said, sophistication?
Yeah, sophistication. That's what I am. Ooh.
I don't know about
Yeah.
that. If you got a comb, I might believe it. Mr. Woolley, your perspective on the science fair this year.
I think the thing that I've noticed most is the enthusiasm of the students. I find that as they have been presenting their projects to people, they just show more enthusiasm. The other thing is that you see evidence of a lot of planning that's gone into projects where they have been collecting data over many, many weeks in order to bring a project here today. And I think I'm seeing more and more projects showing the results of extensive effort over weeks and weeks.
So those of you out there who are looking at this and want to be a part of it, if you're an elementary school student, listen to what these gentlemen said. You need enthusiasm, you need perseverance, and you need sophistication. A little more than what our friend Watson has here.
Yeah.
Actually, he's a good fellow.
Yeah.
We're going to go back and look at the projects before they close the doors down here. We hope to see you here next year at the 1989 Science Fair. Thank you, gentlemen.
Mr. C, look at this one over here. Hey, look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14,
So
15,
this is your project, Watson, huh?
Yeah, sure is, Mr. Z.
Let's see. Now, you listened to what Winnie had to say, and you saw those prize-winning students at the Regional Science Fair?
Yep.
Now, let's see how well you followed the judge's advice and the example those kids set. And we're going to give you some reminders as well, so if you want to take a few notes, we'll put on the screen some things to keep in mind if you want to do an experiment like Watson's here, or one like it. All right, now let's see. What's your title called here? It says, The Effect of Blade Size on the Working of a Windmill.
Yep.
That's very good, Watson.
Yep.
So make a statement in your title. Don't have a question there. And this is a great idea. If you're trying to sit at home right now and think, what can I do as a science fair project? Watson was thinking, we've got an energy crisis. We could use solar energy, we can use energy from fossil fuels, but what about windmills?
That's right.
What's that country, Watson, where they have windmills all the time and they have tulips coming up?
Gee, that's over in Scandinavia somewhere.
Yeah, you're close, Watson. It's in Holland.
Holland. Oh,
okay, the Dutch have windmills.
Right.
It's a cheap form of energy, and maybe we can bring it back. So Watson's picked a good problem to investigate.
Well, you know, Mr. Z, in Southern California, they're experimenting with windmills also.
Oh, listen to him.
Yeah.
He's been paying attention to the news, so it's made its way across the Atlantic. It's here in the United States.
Yep.
So think of a project that has wider implications, not just something that has is just confined to your area. Think about something that can have greater good. That's what Watson's done here. Also, as Winnie said, second point to keep in mind is choose a problem you can handle. Watson can handle this. He's taken some, what are these, Watson? Are these soda bottles?
And these are old soda bottles, yeah.
You're very clever.
I like the first part.
You did? Oh, the part where you got to drink what was inside?
Yeah, I got to empty the bottles. Yeah, that was the best part.
Well, he's recycling the waste. He's not throwing these away. They make for great science fair props in a project. And what Watson's done here is he's cut different size blades in each of these bottles to see which blade size, crooked, straight, zigzag, which one causes the bottles to spin fastest. Is that right, Watson?
That's right.
All right, you've done a good job. I'm really impressed.
They work real
choose
well.
a problem you can handle. Third thing, let's see, what's Watson got down here? Research the problem. He's just told us about California by going through books, as he's done. Check magazines, see if someone's done it before. Help you get some more ideas, and maybe you won't have to repeat something someone else has done. Right, Watson?
Right.
All right. This is a super project. I am very impressed. Fourth thing, limit the number of variables in your experiment. Now, Watson's got a problem here because he's varied the size of the blades. That should be different, but he's using different size bottles. He really should have the bottle sizes the same. Also, the distance from the fan should be the same. Now, this looks good, Watson, but the fan should be the same distance from each bottle, and all the bottles should be on the same size. Now, don't feel bad because you did do one thing right. All of these ring stands are the same height.
Yep.
And they're spinning at different rates, but it could be because they're different distances from the fan. Maybe it's not the size of the blade. All right? Are you with me so far?
Yep,
so
sure I am.
Control all of the variables but one. Something else you want to do. After you've finished your experiment and you've drawn your conclusions, repeat your experiment to make sure that it was valid.
Oh,
so
that's a very good idea.
Yeah, because it might have been a fluke the first time. Try it again before you put it out before the world to see what you've done. Try it to see if it works a second time. And one more thing to remember. Have a large enough sample size. Now, Watson's got 3 different soda bottles spinning around here. Now, he drinks a lot of soda.
Yeah.
I keep telling him to go into the fruit juices, but he says he likes the soda. At least he's into low-cal now, right, Watson?
Well, sort of.
Sort of. So have lots of different containers. Maybe use 10 or 12 of them. Have lots of different designs so that you know when you come up with your conclusion, it's a real conclusion, and you've examined all the different ways you could have done it, and now you know the right one. So if you keep those things in mind, you're going to take home a prize at the science fair. Watson,
Yeah.
I think things look good.
Good,
I mean,
thank you.
You know the judge. The judge gave you advice. We just saw some students that did a super job. So those of you out there that are looking for a science fair project, maybe you can tilt at some windmills or do something similar. So thanks for joining us today on Give Science a Hand. Next time we're back, maybe we'll have a blue ribbon pinned to this guy's chest here.
Oh, that would be nice.
Okay, see you next time.
Goodbye.
Bye-bye.
I got a blue ribbon. Look, it says here, first place, livestock division. Best pig at the county fair. Mr. Z, I'm gonna get you.